Okay, so in this example, we are going to try to find, we're going to find a polynomial with real coefficients with zeros that include 2 and 3 plus I. So in this equation, we're going to use the conjugate zero theorem, which basically states that if a 0 is 3 plus I, then the conjugate also has to be, then its conjugate, 3 minus I, would also have to be a factor of the polynomial. So in this case, we can establish our zeros as 2, 3 plus I, and 3 minus I. So by doing this, we will start with plugging in our equation in factor form. So it would be f of x equals x minus 2 times x minus 3 plus I times x minus 3 minus I. So here we see our conjugates. So this is a conjugate, and this is a conjugate. So by doing this, what we could do is factor out a common number that they have, and we can rewrite this as f of x equals x minus 2 x minus 3 to the power of 2 minus I squared, parentheses. So in this case, we would just simplify. We would multiply, simplify, and if we continue to do this process, we would get x minus 2 x minus 2 times x squared minus 6x plus 9 plus 1. So if we just keep doing this, we would get x minus 2 x squared minus 6x plus 10. And then from this, we would use the distributive property . We would use the distributive property and just multiply everything times each other to get a final answer of x cubed minus 6x squared plus 10x minus 2x squared plus 12x minus 20. So if we simplify this even further, our final answer would be f of x is equal to x cubed minus 8x squared plus 22x minus 20. And this is how we found the polynomial using the conjugate zero theorem.